Hello everyone, I'm Strictly, he's Quantum, welcome to Donut. I'm just kidding, welcome to Strictly Quantum. Again, we haven't had this chat in a while. Today we have a very special guest star, it's Roman, aka Der Bauer, the famous inventor of exciting PC related things, extreme overclocker. Have I filled everything?
Yeah, it feels like a long time since we've done a stream. I don't know why. We did so many Rate My Builds that it seems like a long time.
So we're doing a live stream. We are having Roman here. Do you people see Roman? Yes, you do, right? Roman, wave to the people.
Hey, yeah, I'm here.
He's
Thanks for having me. Thanks for the kind introduction. Yeah, and looking forward to some direct eye talk.
Did we miss anything from the list that we said?
I think you got the most important things.
Good.
I mean, there's a lot of stuff really, like doing the thermal grizzly stuff, YouTube mainly. So yeah.
Yeah. So you have really changed the appearance when you started doing your like own content, reviewing things as well. Because before, when you started the delidded tools and stuff like that, you were only present on the market as a extreme overclocker and then starting to do these accessories. But since everyone's here and we have Der Bauer here, we will hit off this Strictly Quantum with some topics related to delidding and things like that. We have some EXPO products here, we have some Der Bauer products here, we have some competitor delidding tools here as well from Rocket, but we will start off with the first topic about what is delidding. We will also have a set of images shown onto the screen so that people know that what we are talking about. So EK also has a quite successful blog post on the subject of delidding, and the most basic explanation is that we are removing the IHS, which is the metal part of the CPU cover, removing the rubber which is holding it down, and then bringing the metal cover closer to the die. Roman, Joe, did I get it correct?
That's pretty much a summary, I would say. Yeah, just remove the lid. That's why it's called delidding. Yeah.
Delidding. Yeah. So many people don't know why it's called delidding, because so the IHS, or the integrated heat spreader, is the lid, and you remove it and then you put it back. But later we will come also to the part when you don't put it back. So that's where things become interesting. We should also see a picture about how did my first delidding look like back in 2017. And I will also ask Roman, how did his first delidding look like? Can you walk us through?
The first delidding I did was with 3770K, so that was quite a while ago. I think it was like 2013.
Ivy Bridge, right?
Ivy Bridge, yeah.
Yeah.
Because back then it was the first CPU that changed back to polymer TIM after Intel had soldered TIM on Sandy Bridge.
Sandy Bridge, yeah. I had the Sandy Bridge 2600K, and it was a very good overclocker. And then they moved to Ivy Bridge, and I know that the 3770K, right? That was already problematic.
Yeah. So I mean, on that CPU, like delidding was not that common yet. But for XOC back then, when we were hunting for records, because Ivy Bridge was going full out, so you could go like all the way to minus 200 degrees Celsius with liquid nitrogen. And so we were looking on anything that could help us to get even lower in temps, like in deltas. And yeah, at least for XOC, delidding turned out to be not a good idea, because it was like introducing too many
Shocks.
different parameters, and so yeah, the results changed quite a bit. So
yeah, but how did you delete your first CPU? Did you use the vice
with
method
the razor
or
blade. Razor
the
blade.
razor blade? Oh, brave.
I think back then in 2013, the vice method was not that common yet. I think this mainly started after I was doing the delidding tools, because when I showed the first delidder, which I think was in 2015, I was I was using this kind of shear method in my head, and then it got more common that people said basically the delidder is a huge vice. So the vice method became more common. So yeah.
Joe, how did you do your first one? Did you ever?
I just got 8-pack to do it with his bare hands.
Ah, okay.
He had the CPU, Lian. Yeah, and I remember I put it back together with paste again because I didn't want trouble with liquid metal. But you know, a much thinner application because it got all of the glue off. Put it back together with paste, and I think I still have it with an air cooler somewhere.
Oh, nice.
So it ran quite nice.
Next topic, obviously, the most important is delidding dangerous. Roman, yes it is.
I mean that's the reason why we started with the delidders, right? Because when I did my first CPU, everything was going fine, but when I did a second one for testing, I cut with the razor blade into the PCB, and the CPU was just dead. And I was like, wow. Nice, I just wasted $350, and at that time I was still a student, so I had to save up, I think, another 4 or 5 months to buy another one. And that really hurt. That really hurt.
So I must also confess something, that when we were shooting that build, that one there, it was the first time that we got the EK delidding tool, and it was a 13900K out of the box, brand new, and I put it into the tool.
It was really new then as well.
Really new,
yeah.
And we were recording at the time, and I was rushing, and I managed to move some SMDs off the PCB.
Yeah. This might even be an opportune moment to unbox it and talk about what you did, because someone might learn something. Basically, I had the first sample, one of the first samples that fit the CPU nicely. I gave it to Attila and told him what to do, and came back a few moments later to, have I done this right? I don't know, people are running around here looking for like SMDs on the floor that just invisible. And I was like, no. He said, well, you didn't tell me it could go this wrong.
Because every CPU that I have delidded before didn't have SMDs on the outside, so it was just like moving it to the side. It was only important that you don't move it into the die if it was like a long die, so that you move it sideways, and that was all I've followed before. So we know that there is a risk, and that's why we have good tools that we will come to later, so that you minimize that risk. But now that we have talked about risk, does the risk pay off? So Roman, Joe, what do you think? And also the audience in the chat, feel free.
I think it mainly depends on the generation. Like we saw huge jumps, especially on all the polymer CPUs, like from 6700K to 8700K. There was a huge benefit doing it. Then on 9900K, the benefit was a bit lower. Same goes for 10900K. But after these CPUs, because the power density increased even further, like on the 12900K or 13900K, just getting rid of the solder layer and making it thinner already had a benefit. So I think on recent CPUs, if you go from just like stock operation with a normal block to like direct die, it's an easy gain of like 6 to 8 degrees Celsius. Could be more in theory, but I would say that's like roughly the average. And if you think about if you have a water cooling setup and how much money you have to invest to get like 6 to 8 degrees lower temperatures, then usually delidding is worth it.
And that's what will bring us to the last topic of this live stream with their power. But before we go there, I just want to mention that there was a huge debate when like people said that that like delidding is dead when they went back to soldered heat spreaders. I was also like, well, that makes a point because you have to clean the liquid metal, the indium. You have to physically scrape it, but there was also something that was very new to me, that you can use the liquid metal to actually clean the indium of the CPU, and it's way less aggressive than like going to it with a razor blade and scraping it off.
Yeah, I mean, in the end, the solder thin layer is just indium, and liquid metal, at least it depends on what kind of liquid metal you're buying, but the base materials are always gallium and indium. Most of the other vendors are adding tin to it because it's like stretching, you know, like you can make it a lot cheaper by adding tin, because like a kilogram of tin costs like, I don't know, like 20 euro, and a kilogram of indium is like 500. But basically this metal already exists in liquid metal, and if you add any kind of liquid metal to the solid indium, you can use it to kind of dissolve it, so you're just changing the composition of the liquid metal.
Do you know who was the person who has discovered this? Was it you, or you have picked it up somewhere?
That is a really good question. Because, I mean, at a certain point I saw that, I think it was Rocket Cool, they're selling something that's called Quicksilver, which is just a liquid metal. So they definitely used it. Yeah, I'm not quite sure who was the first to do that. I mean, that's like, it's like basic physics that has been out there for, I don't know, like 20, 30 years at least.
Okay. Next topic, question number 4. When did delidding become mainstream? So what do you two guys think, when was the point that when delidding became mainstream? I think that was around the point when like even EK did the direct die Ivy Bridge standoffs for the Supremacy Evo. I think that was around 2013, 14?
Yeah.
When it like really picked up that, hey, you can do this, it is not all that hard. So what do you two think?
For me, I mean, it's been kind of funny because we've been delidding for different reasons. Like when Ivy Bridge came in with the what was considered horrible thermal interface between the IHS and the die, it was still a relatively big process node, and it didn't have any density issues. It was a massive CPU for the core count compared with what we have today, so it was kind of just removing that thermal barrier. It made a massive difference, and I think that's when we saw most people attempting to run like direct die with die guards as well. I think that's also about the time that Roman pioneered the die guard mechanic, and then we saw now it kind of came around in full circle again. Intel gradually improved their interface, but at the same time, the process node got so much smaller that now it's solving a density issue. So I think now it's become necessary for everyone, whereas at one point it was necessary for people chasing the last multiplier, the last few. Whereas I think now it has like a genuine performance benefit for every application.
I think we have a photo of Roman's first official delidd tool, right? This was the first one, the delidd die made.
Yes.
Yeah, it was made from acetal. So what do you think, when was the breaking point when like it became mainstream?
I mean, at that point when we made these tools, that was when it started to become a more mainstream thing, I guess, because it eliminated the risk for the user to do the process. You could see enthusiasts doing this like already 1 year at least before, especially with your precise mount kit, because it was kind of eliminating the mounting risk. And after the tools became more common, by the way, also because I'm not sure if some people know that, but we made a first batch of this tool of about 500 pieces. And when this was gone, the second batch was actually done by EK. So yeah, we already started our cooperation there. I think it was like 2016, maybe. I cannot remember. Yeah.
I came to EK 2016, the end of the year, so December. So if it was a bit sooner, then I just missed it. So I didn't know that.
Yeah,
I didn't know, but I also wasn't here, so
yeah,
that's cool.
Yeah, so the first batch was done by you guys because the second batch, because the first batch I made was I made it with a local German machine shop, and manufacturing in Germany was a bit more expensive, and so I didn't have any kind of resources or contacts to do it, and then somebody from EK reached out to me and said, hey, we can do it for you, and then yeah, that was the first EK co-op I did.
Ah, cool. So we launched their bar. Joking.
I mean, you were an important part to make it more mainstream for sure.
Yeah. Yay. Now that we are talking about the tools, let's jump to the next topic, and that's the evolution of the tools, because it's a simple thing, but it also gets more challenging with the different generations of the CPUs. So here we have the Rocket tool, which is just a simple push thingy, which would push the IHS to the side. Then we have the delidding 2, which also just this pulls it, right? So
yeah.
this is a bit more safer, because you kind of I think the force is also more stable, right? Because you're pulling it.
Yes. Yeah, that's what. Sorry, Joe, go ahead.
Yeah, I was going to say, like, at the moment when it releases, when it breaks, it's already come to the side.
Yeah.
So it doesn't just fly off and rip through everything.
Yeah. So that's a like evolution. Then here somewhere we should have our. We should also see some images soon coming to the screen. We should see the delidding for the Intel HEDTs, which was using a lever, right?
Yeah, that was for 2066.
Yeah. Was that solder, right?
Yeah,
No.
yeah. Depending on the CPUs. Yeah, like the 7000 were polymer TIM. Yeah.
Why did you have to do the lever? Was it like so glued, or was the surface of the glue so big so that you have to use a lever?
It was because we had different CPUs, and the mainstream high-end desktop CPUs for the normal consumer market, they were using polymer TIM, but there are also other CPUs out there that are using solder TIM for the same socket, and we had to make sure that the tool works for both. And because it had this stacked PCB layout, it had like a double amount of glue, and we just had to apply so much force on the soldered CPUs that, even I think we used M8 threads, and even they broke. So we had to use a lever, which was like a 1-to-3 ratio, so it could like triple the force. Yeah.
So here we have the tool, which is the collaboration with EK and the Derbauer. This works for 1200 and 700 series as well. And the trick about using this is that you have to flip this insert. Maybe Joe can explain so that I don't do the same mistake.
Yeah, sure. I'll demo it again. So when the CPU is inserted to the base, there are two positions for the little triangle for the index marker. There's position 1 and 2. And the first step is 1, and when it's in position 1, the IHS gets pulled. Then the IHS gets pulled away from its original position, and to do that, the slider also needs to correspond to position 1. So the CPU sits with its triangle in 1, and the slider goes face up, so you see the 1 on the top. And then the first time you pull that, it's going to move the CPU away. And if it's a 12th gen CPU, then you should have these screws installed so it can only move 2 millimeters. That's because there are some SMDs underneath the IHS, and while the IHS won't hit them, like the gallium can break off and that can go and dig under them or short them and cause an issue. So just to have some safety, only moves 2 millimeters. But with 13th gen, you can take those off and it will move twice as far. And then once it's moved to the side, you flip it and put it back in its original place. And from repeating that a few times, so the CPU gets rotated 180 degrees and the slider gets rotated 180 degrees over. When it goes back inside, no matter if the screws are installed or not, the IHS goes all the way back to its starting place. With the big travel for 13th gen, it typically falls off first or second try, and the 12th gen, safer to do 3-4 tries and then start to lever it very, very gently, and not to put your tool down towards the PCB, like keep the pointy part picked up away from the PCB, and it comes off quite nicely.
We will also make sure that we have a like full instruction video on all of these delidding tools and also the upgrade kits. I think that here we have the replacement ILM. So this is not for delidding. This is only if you are using an EK. Actually, it is.
What do we have here?
This is the there's a foam in there, but this is the replacement ILM. Let me check. Yep, this is only if you are using a standard velocity CPU block and you want to make sure that the CPU IHS is not bending, because that's a new problem that came to the market for some reason. And then we have the upgrade kit, which will allow you to upgrade your regular velocity CPU block to a direct die CPU.
I want to add something, if that's okay, to what
sure.
Joe said regarding the delitter. So for the 12th gen, we never released a delidding tool because I considered it not safe enough. I know there is a tool from Rocket Cool, and I can tell you that I received several emails of people with like damaged CPUs, and the reason is exactly what Joe said, because on the 12th gen you have tiny SMDs like 0201 SMDs close to the die, and on some CPUs the indium is positioned differently underneath the heat spreader, and the Rocket Cool tool is pulling it to the side. And if you are unlucky and you have one of these CPUs that has the indium a little bit to the side, your CPU will be dead. And like soldering back 0201, yeah, it's not going to happen by hand. And I mean, like most of the times you're also ripping off the solder pad, and that's why if you look at the tool from what Joe made, it might look like overly complicated, but I can tell you that's like the perfect solution around this problem. And that's also why it might be more expensive, but you should rather pay more on a tool that's safe for delidding than risking your CPU. Because in the end, what people should always keep in mind, these tools, if you used it, if you delidded your CPU, you can sell it on the second-hand market, and in the end, you paid maybe $20 for delidding. So yeah,
sell it or
give it to your friend and tell them to get a block too.
Yeah, that's fine.
Good one.
So we have the direct die kit. It also comes with liquid metal inside it, so that you can clean the indium of the die. And we also have a sample of the limited edition block, which sold out in less than 1 day. Where do I put this?
How do we have it then?
We have it because this is number, what is this? This is number 42.
Is this the one you wanted to send to me?
No, no, you will get number 8 soon enough. I was told that this is in production right now. This is number 42. 42 is still up for sales. So we have 13 and 42 reserved for now. So this kit came with the delete tool, and also, does it come out like that?
It does, but you might need to take things out to grab
I
it.
have to take things
because they're heavy.
And then you have the same kit as you get with the upgrade kit, everything that's needed, so the liquid at all and the tools, but of course this already has the direct die cold plate on it, so that you don't have to change anything. I'm gonna put it back, so maybe some famous influencer will get number 42 one day. But I've just touched it. Is this the one? Yeah, that's the one, because it has the screw, so I'm gonna put it back so that I don't damage it. And then we will move along to the next topic, which is Der Bauer's role in delidding. So, when was the first time you started, and where are you now, and what do you think where it will go in the future?
I mean, when we started doing delidding, like the very first tool I made 5 pieces for me and some of the overclocking friends. I didn't think it would become a thing, but turned out that there are a lot more enthusiasts out there than I expected. And I mean, personally, I enjoy building these, like the AM5 one we made here, and even though it's still a niche market, it's not like millions of people are going to delete your CPU, but I honestly enjoy looking at the challenge, especially like for AM5, for example. It was pretty complicated to make it reliably, but doing something like this, like having the challenge and making it successful, I really enjoy it. And yeah, whenever there's a chance, I will build a new one. So
we also seen one of the latest delete tools is for the, what's the socket name?
4189?
Yeah.
What?
Yeah, right. The really big one.
That was 3467, right?
Yes.
But that was already for the Xeon 3175X.
Yeah.
So
I think we should have a photo somewhere in the video editing team. What do you think about 4677? Would it be deliddable, because you have been at Intel recently, right?
I looked at this, and like honestly, I mean, there's always, if you assemble something, there's always a way to disassemble it, right? It's only a matter of how much effort you want to spend on it. But the honest answer on those CPUs, it's not going to be possible with a simple tool, because it's using so much glue inside, and some of the glue is contacting with some SMDs. So even if you wanted to move it back and forth in any kind of way, there's always a risk that you're going to damage some SMDs. Yeah, I had a very interesting demonstration at Intel how they are delidding CPUs, and actually saw them delidding a Sapphire Rapids CPU. The only thing is that I'm not allowed to talk about it, unfortunately, but they can do it, but it's very complex. It's very complex. Yeah. So yeah, unless you want to spend, I don't know, $1 million on a machine to delete it, I think it's not going to happen.
Yeah. $1 million.
Yeah, $1 million.
We're gonna have the Bauer SMD reapplication kit coming soon.
DIY solder experience.
Next topic, Der Bauer on his homepage has a list of CPUs which are also sold on Case King. I don't know if it's available for the last few generations, but before you would be able to buy a binned delidded CPU, and then you would have the engraved Der Bauer logo on it. I think I even have at home the small wooden keychain of a signed
nice.
Der Bauer IHS from I don't know which CPU. But what I'm interested in is who was deleting these CPUs. Was it yourself, or you had an employee do this?
So when we started doing this, and when I started binning CPUs at Case King, I binned personally over 4,000 6700K CPUs. At that point, I decided I'm not going to do this again because I basically spent 3 entire months of my life just putting CPUs in the socket, testing, take them out of the socket, delid, and apply liquid metal.
Time well spent.
I got a good routine, but yeah, that's not enjoyable. So at a certain point, also because I mean you never distribute one single workload to a single person. So we instructed people at Case King how to do it, and they started doing the binning and also doing the lidding and everything. It was always me like looking over it, checking everything is going according to plan, but like with the amount and also the workload, it was just not possible for me to do that myself.
Before we have 2 questions picked for Der Bauer by Joe.
Yay!
We will move on to the last topic that we have on this direct die thing, and that is direct die AIOs. So we have a prototype sample of a direct die AIO. This is the Nucleus Dark. This is actually a unreleased AIO. We will talk about it later because it has no RGB, but the cold plate has been modified a bit. This is the original cold plate. Here are the fins, so this is how it looks on the inside, but the cold plate is made that it would contact the die directly on the 13th gen. So what do you, Joe, think, and what does Roman think, and what do the viewers think about direct die AIOs? But before you start talking, I'm gonna talk a bit. I think this is a very good win-win for everyone, because so far direct die was available only for custom loop. So you would have to get the whole shebang, the whole custom loop, in order to just remove a barrier which was there because of the way the CPUs were made. And if you have a direct die AIO, sure, you will have to pay for the tool, which is 40, 50, 60 bucks, but it's way less cost than if you would have to do the whole custom loop just to have direct die. So I'm gonna let Joe first.
So I'm super excited about this, and it's actually the first time I saw it. I gave the instruction for people to do it at any cost just before Christmas, and I just got back to see it, and it's awesome. And that's the stock one.
Yeah, the stock one.
And this is the direct die one, which looks like it's going to fit with the debauer parts for now. And I really can't wait to test this, because the Nucleus in its own right performs amazing. And it was always good on Alder Lake, so I'm really excited to see how it does. I'm curious about the Sky fins, because it's a little bit different. And one of the things me and Roman were discussing when we were building the direct die blocks was actually the thickness of the base underneath the fins. When we're building a block for an IHS, we try and get them as deep and as low as possible, and it's the same for AIO. So typically there's like 0.4 of a millimeter beneath the fin for our blocks, but with no IHS, there's actually a bit more performance to get out of it by spreading the heat and effectively incorporating part of the heat spreader in the cold plate itself, and it worked really nicely for that, and I can't wait to see how it works with Sky fins. It's going to be a fantastic product for, you know, almost AIO money, that you can instantly just drop 8 degrees from your CPU temperature.
Or more if you have an unlucky sample.
Yeah, and if this gets entered into the mainstream cooling product on everyone's review site, it's going to look insane.
Roman, what do you think?
Yeah, honestly, Joe, I'm really happy when I see these kind of innovations, and I mean, it kind of is an innovation, right? It should be the first direct die AIO. So yeah, Big respect from my side for that. And yeah, I just want to see how it performs, but it's a really cool thing to see this coming even more to the mainstream market. Just one question, like a technical question from my side. Are you going to nickel plate it?
I think probably not, because the stock one is bare copper, but it's a fair point for liquid metal that nickel plating would be better.
I think we would have to somehow protect the fins from being nickel plated.
Yep.
Because they're way too fine to get nickel plated.
We did some with a different AIO brand. I was doing a cooperation a few years ago, and they were looking into nickel plating the base, and it seemed to be quite difficult with the sky fins. I'm not sure, Joe, do you know why that's the case?
Yeah, because it's just thin.
Yeah, because the nickel wants to spread itself over the whole surface. Like it's submersed when it's applied, and there's you know, like a electric difference between the anode, which would be the piece of copper, and then effectively the electrodes in the nickel plating get attracted to it. They try and spread themselves perfectly evenly, so stopping them go inside something that's you know, completely conductive is really hard.
But I mean, you can use chemical nickel, right? So
yeah, but this is still so fine that you can't even see the fins, so that if you would start plating this, it would just all melt into one big
so it's
structure.
Like blocking some fin. Okay, that makes sense.
If it was like isolated in some way, I don't know that it was constructed that there was like some kind of insulator between the inside and the outside, which would ruin it as a a cold plate. But
I guess that we will also see the feedback of the market. Are these people who are interested in like AIOs want to go all the way to liquid metal, or just having a good paste is like going to do the job? So a lot of testing here has to be done. Like I said, this is just a prototype that we have here, but hold on to your pants. We will do a sample of the DeltaTech 2, which is a direct die version. We have also spoken to Intel, and they said that the current software and everything should work, that no changes need to be made to it. So we're also working on a DeltaTech 2 sample, so that we test the limits of the CPU when it's doing the cryo cooling.
Nice.
That's about
Very
it
nice.
then. Yeah. We can also make two and send you one if it works.
Yeah. I mean, worst case, you always have to use a donor software system, you know. I also talked to Intel about the software, and they made it much more intelligent now than it used to. So they have some parameters where they're double checking like the relation between the cold plate and cold plate temperature and the core temperature, if it's like changing as expected, and if not, it's popping up errors. And
they said that it's fine, so we will try it. Also, we should have a topic along the line 0.19, but we will do it right now because the chat is exploding about AM5 direct die things from EK.
I wondered how I was going to keep that out of my 5 questions for Roman. Because that's all anyone asks for the last 20 minutes.
Okay, then let's go to the questions, and Joe and Derbar will work out 5 questions.
Okay, so things that I've seen during the chat, you're going to get at least 3 of them, and then I'm maybe going to make 2 up.
Okay.
Someone asked, how long does a application of liquid metal last? So will it degrade faster than thermal paste, or will it be a kind of good for years and years?
So I mean, liquid metal generally it's not a fluid, right? It's or it is a fluid, but it's not, doesn't contain any water, so it doesn't dry out. The only thing is that you have interaction with the contact surfaces. So for silicon, it doesn't really react with it. That should be fine. For the contact surface of the cooling block, it just depends on what kind of metal does it contact. Like, is it just bare copper, or is it nickel? Is it like a thicker nickel plating, like you call it hard nickel plating, or is it normal nickel plating? There are a ton of different factors, and it all comes down to if the nickel will form a kind of alloy on the surface or not. I can tell you that internally we are experimenting with a lot of different alloys, because we're also producing this in Berlin, the liquid metal we're selling. And we are experimenting with different alloys right now that have different behavior when it comes to the, like what you call dry out. So there could be ways to, or there could be some stuff we release in the future that might be more resistant to what you call the dry out.
Okay, cool. And what else have I seen? Avoiding AM5 questions. That's an AM5 question. This is tough. That's they keep baiting me in with different words, and then it ends in AM5. Does liquid metal corrode GPU block? Okay, now we're talking about GPU application.
Okay.
So yeah, would it have a different effect on a GPU than a CPU?
It's the same thing. So it's just a differently shaped object, but the conditions are the same. Yeah, I would say for GPUs it's even better, because you have less hotspots, which cause like a more uniform load across the material, because also the heat will accelerate this kind of like alloy forming that you can see. So on a CPUs it's more a problem than it's on GPUs. So on GPUs it's typically fine. The general rule of thumb is that whenever it's a nickel plated block, it should be fine. And it just, what I personally recommend is that you just apply it, you check how is the condition on the first day, note down your temperatures, and then you check back, let's say maybe once a month or maybe once a quarter. And if there is a drastic change in temperatures, then you might have to reapply it. But that's basically it. Also, what people should keep in mind is that in some cases, when the liquid metal becomes hard, it can actually be better in temperature. So that's one thing to also keep in mind, because a metal in solid state always has a better conductivity than in the liquid state. That's just physics. Yeah. And whenever, as long as it's filling in the gaps, it could be that even if it's like hard, it still performs really good. So yeah, just watch the temperatures.
I have one question.
Oh.
I haven't done liquid metal a lot, and when I did, the only comment that I got from people that come in and are being smarter than me is that you are putting on way too much. So so for a beginner, how do you define what amount of liquid metal is enough? Because for like paste, everyone knows grain of rice, and that should be good.
Yeah, for me, for liquid metal, it's if you apply it, we call it, like, you can see some kind of lakes building up. You should not see that. You just have like a very thin uniform layer, but not like a lake building up on top. Yeah, and so, also just use like as little as possible. That's also very important. I mean, worst case, it was not enough, and you have to open it up again and you add a bit more. That's like the worst thing you can have. But if you add way too much in the first place, then I mean there are other risks, so that should be avoided.
So there, I have saved you one question.
Cool. So I want to ask a little bit about die guards, because that's one thing we've not mentioned through our look at the products so far, but I think it's a really important mechanical part of avoiding the relidding process, but using blocks as being directly exposed to the silicon. So when was the first die guard? Did it come about at the exact same moment you delidded the CPU? Was that always the intention, to put it back with nothing?
I actually released a die guard before I released my first delidder. So the first die guard I made was for Ivy Bridge and Haswell. That was quite a while ago. And after that, because that was also like a strict extreme overclocking tool, we made 50 pieces, so it's like yeah, not really a commercial product. Because back then when we saw going direct die for liquid nitrogen cooling, you have this 2 or like 3 kilogram heavy block you put on this tiny chip, and you know that if you move it around a little bit too much, it will just break the die. So we made those like tiny frames to have like the same kind of level to protect it. And that was also something we figured out later, that there is a market or request from the water cooling community for this.
Yeah, I remember that our first blocks, I mean, before we had any kind of dedicated direct die block, that the cold plate was too big to fit inside the little posts on the corner of the socket.
Yes.
And the die was actually lower than the socket.
Yep. And you had to file down the...
modify the socket a little bit. Yeah. That's awesome.
That is probably the most hardcore stuff you could do back then, like modifying your socket, those like so close to the pins. Yeah, respect to everybody who did that, really.
Just hope all the plastic dust comes out.
Yeah.
So the die guards that we have now on the direct die stuff that we did together, it's much thicker than our blocks than they were back then, right? So is there any benefit to this entire like rigid assembly that we have?
I mean, I think the way you're doing it is like the best technical way you could do it, because the thing is, whenever I made a die guard, I was always looking at this from like a universal standpoint. So I was like trying to get this as universal as you could do it to fit any kind of cooler, like even like air coolers or whatever. But if you are making the block, then you don't have those limits, because I always have the limit that you clamp down the entire block. So you have some kind of height limits, but if you can modify the cold plate and have it stand out like you did on the EK block, that's like the best possible technical solution, because you can make a much more rigid, much more thick die guard. It's going to be so much better for your main board, so much safer for the CPU. So yeah, that's the ideal technical solution. Yeah.
Thank you for the advertisement, because people were like comparing other die guards which are available on the market, and like they were saying like EK is twice as much. Yes, because you have the back plate which is in the same assembly, and you have to have a special back plate if you want to use either the ILM replacement or the die guard which is used with the direct die blocks.
Yeah, so but that will be from us. Of course, always the option to take the Thermal Grizzly die guard and use it with the original motherboard, original Intel backplate, which Roman found out from the screws on there can get a bit difficult, that they're kind of strange to torque back, and we're using smaller M3 screws for ours, because we made everything again, purely because we didn't want to make like exactly the same thing that you can get from Thermal Grizzly already. And you know, as also the backplate, not only is it specific to the block and specific to the ILM replacement, but it also replaces the Intel piece. So this is like 6mm thick in the middle, and it's really as much reinforcement as you could possibly give to the motherboard. In practice, I think if you're comparing like for like, very similar, but it's a really elegant way of including it with the Velocity 2.
Yeah. That was the final question. Robin, thanks for joining. Do you have anything to add or share with the people which are watching us?
I mean, I just want to highlight that in the end, I find it amazing, and also want to thank you guys again, because if you look at this, we could be some kind of competitors as well, like Grizzly or EK. Yeah. But I totally love that it's possible in our industry with guys like you that it's no issue just like cooperate on things like that. Like if I see that you can make the best technical solution because you can modify your block, then like that's why I'm totally open to this, because I think whenever there is a way to improve things, you should do it. And yeah, no matter what. So that's why I want to thank you for doing these kind of co-ops. It was really enjoyable, and I also learned some stuff. So yeah, thank you.
So maybe that's a wink nudge for like AM5 stuff. Stick around and follow Roman, follow EK to learn if there's going to be an AM5 direct die thing. Obviously the tool is out there. So Roman, thank you very much for joining us. Now we will move on to the show of Strictly Quantum, and where we will talk about custom loop liquid cooling and also some AIOs as well, which we have spared there.
Cool.
Joe?
Thank you. Bye bye.
Yep, thanks Roman.
Thanks Roman.
It was awesome to have our first special guest, and while we're saying thank you to Roman, also like to say thank you to KitGuru for kind of starting up the whole direct die thing. It has been a really fun journey, and I think it's been a year now, and the products are actually getting ready to ship this week, so that's been sweet.
That's why KitGuru is getting #1. Thanks Roman. We'll see each other soon. Bye.
Bye.
Anyway, let's move on with the show with a very special monoblock thingy, which we should get a picture from the editing room back there. We'll wait for a second for it to appear. It's a monoblock. It's gonna be big. It's gonna be expensive, but it's also gonna be very clever. I will let Joe start talking about it.
Yep, so first off, this is a product for the Z790 Extreme from Asus. So we really wanted to move things forward another level with the Extreme because you know, in the past we'd had Glacial collaboration with Asus, and you know, we kind of wanted to fill in some of the premium features and really give a kind of middle and awesome step between the two things. So we also took a pretty unique approach to it in that the block and the heat spreader are all kind of totally separated from each other. So there's one big, huge single piece of aluminium which screws to the board. That contacts all the VRM, the LAN controller. It goes under the PCIe 5 M2 and goes, you know, everywhere it's possible for it to reach at the top. And that has like a little contact patch for the lighting. So there are pins on the base, and it comes with a wiring loom that reaches perfectly to the headers on the motherboard. And then the block drops in from the top, sits on the CPU with paste, and sits on the VRM with thermal pads, and again on the M2 heatsink. And it comes together practically with 4 screws just from the socket. And in doing that, the electrical connection is also made. So we make a thermal and electrical connection simultaneously, and then there's kind of no wires on the block at all, and it immediately connects the RGB, connects the flow sensor that's inside, and it connects the temperature sensors, 2 temperature sensors in there. So it's a really nice package for the board. We have seen a 3D render from the front side, and it has 2 ports on the bottom. So it has 2 regular ports like a Momentum monoblock would have, and there are 2 ports at the bottom. What are those 2 ports for? So this is a bit sneaky, and it's a lot more than just ports. So you know, at first it looks like maybe we just, you know, simply integrated the distribution onto it. So it has the 2 standard Matrix 7 foundation placements for the CPU inlet and outlet. Then there are an additional inlet and outlet that correspond with the position of the ports on our GPU blocks, including the active backplate sets, whether you have it horizontal or vertical in one of our brackets. So you can connect the GPU directly to the monoblock, or you can also run into the GPU, through that, return from the GPU to the monoblock, and then exit from the monoblock. So you'd have just 2 ports to connect both blocks. Yeah. It's really awesome combinations, and it's made possible with a pair of valves behind those 2 ports on the bottom. So when a plug is installed, it pushes down on the valve stem and opens up an extra route for coolant to flow all the way through the block. So from the very first inlet port on the CPU, through the bypass and out. But when you remove those plugs and install fittings for a GPU, then the valves close up and it forces the coolant through the GPU, returns to the board, and then passes over the M2 heatsink and all around the whole socket.
And then someone said that the direct die AIO is innovative. What about this one? This special edition monoblock is April, May, so it is not really close to the launch of the Z790, but we are doing this to show what we are capable of, and probably we will also win the hearts some enthusiasts which would want to have the best cooling solution available on the market, which is also aesthetically blending in with the board and also other EK liquid cooling products. So
yep, and another cool thing is that with the 4 screws you can just remove the entire monoblock and just drop on an AIO, drop on a CPU block or whatever you would want to do for
testing,
you know, any length of time just to test the system. So the aluminium can stay once your board is equipped for that monoblock. You still have like a full VRM heatsink with proper heat fins, and everything's going to be fine.
It will also have some sensors, right?
Yeah, the sensors are integrated in the block part, and as soon as you drop it on, it makes electronic connection with the base, which is permanently wired. So just push it on.
Cool. We have talked about the probably most advanced monoblock that we are currently making, and now we will move on to monoblocks which people thought that are hoax. So we had comments, people saying like, what is this? This is not a monoblock, this is just a CPU block. So the monoblock which we made for this is Z790i, and I think today we launched the X670EI monoblock, which looks very much like a standard EK CPU block, but this one says velocity and this one says momentum. So the difference is that when we did the MSI torpedo project, we have discovered that just by touching the VRM with the block itself, you are able to bring down the VRM temperatures significantly. That's the idea on which we just built on. So here we have the monoblock for the Z790, which from the front side looks like a CPU block, but from the back side, let me just remove this backplate. So the entire stainless steel part which is present on the CPU block is here replaced with a nickel plated copper piece, and these contact patches are contacting these flat surfaces on the stock VRM cooler, and this in general brings the VRM temperature down by 20 degrees, which is a huge difference just by touching the integrated heatsink with the block, which is directly cooled with liquid.
Yeah, and that's also comparing it on an open test bench in favorable conditions, but these tiny boards might go into deployment somewhere entirely different, where it's
very tiny,
sandwiched by a GPU and a solid case on all sides, and then this will have an even more profound difference, especially considering how dense the VRM are.
So here we have a stainless steel plate which the whole CPU block builds upon, and here we have a copper base which the whole block builds upon, and from the front side this looks very familiar. This is not a plexi version, so we don't see it. This one also looks like a AM5 block, but it's a little bit different. This is maybe more considered to be a monoblock, but it works on the same principle, where you have the copper base touching the stock heatsink on the board. This would also make things much easier for the user, because these boards are getting so densely packed, and you have all of these layered boards. If you would want to do a real monoblock, it would complicate the disassembly of the board. Things can get damaged, and this is just a way more elegant way to bring down the cost of the block itself, make it easier for the customer, while still achieving very good results, because 20 degrees less is a big difference. Did I miss anything, Joe, here?
No, I just think these are super cute, and you know, I mean, partly yes, these look like a velocity, but the velocity also looks like a monoblock, so that kind of checks out. It's a very similar principle to what's being used on the Z790 Extreme, but it just so happens that these motherboards are practically pre-equipped with a heatsink that can make easy contact with the block.
Fun things we have seen. 2 mini ITX boards on the market. One is from MSI and one's from Aorus, which has the same flat heatsinks around the VRM. We will also investigate how heavy changes do we have to make to these CPU blocks so that we implement the same cooling onto those boards. So if you have a preference, or if you see any boards that have a similar cooling solution where you have these flat surfaces which are inside the Intel keep out zone, let us know which one you favor. Write it in the comments, and we will see if we can make a mini monoblock for that motherboard as well.
Yep, and it's also possible that these may be deployed on other boards with just a different thickness thermal pad, which brings me on to another interesting thing of if you would combine this with the products we were talking about earlier, the direct die and the ILM replacement. So the ILM replacement kit would just instantly work with any of our monoblocks, any Momentum 2. So you would just fit that first, the backplate will be permanently mounted, and then this would drop straight on with the ILM kit. You could also convert it to direct die, because the cold plates on all Momentum 2s are cross-compatible with the direct die cold plate. The only thing to watch out for is you need to check really carefully that the thermal pad engagement and the liquid metal engagement remain suitable. Be a bit more cautious than usual when you first test the thermals, because you won't have the kind of unlimited application pressure that you do with thermal paste, because the direct die guard itself protects the silicon by interfering with the cold plate and stopping it going too deep. So that may affect thermal pad fitment, may need to adjust thickness or placement, and the same with liquid metal.
I have a plot twist. Before you started talking about, you said that you have one more thing, and then I got the idea, and if Billzoid is watching, or you can ping him, Billzoid was doing some interesting things about putting thermal pads around the socket and then putting on an AIO, and he would just cool the PCB around the socket.
Okay.
And by that he lowered the VRM temperature. So I think that we will also play around with this, because you can just stack up millions of pads, because this whole thing is copper.
Yeah.
So that you can also try lowering VRM temperatures like that on any board.
You could, but I think there's practically no space left on a board like this.
Yeah, but if you put it on a normal ATX board.
Yeah.
Okay. We'll see if Billzoid picks up on that or not.
We had done that in the past in a very extreme scenario with a I can't remember the socket, but the board that the Dominus was based on, that socket, there was also an Aorus board, or it was put out by like Gigabyte.
Okay.
And the power delivery came between the memory banks on both sides.
Yeah.
And it was such a small piece of PCB, and it all came from above, that the PCB could actually practically overheat between the CPU and the power delivery. So we had temporary solutions with extra pads just to cool the PCB. Just
to make it work. Moving on to, we should have had the AM5 announcement. Oops. Direct die thing, we have talked about it. So if you're interested, subscribe to the EK YouTube channel and subscribe to our newsletter. and maybe you'll find out more things about AM5 direct die cooling. But now we're moving on to distro plates, but first we are moving on to distro plates and cases. And by saying cases, we have some bad news.
Yep, there have been a few questions already.
Yeah, I would ask the video edit to show picture number 20, which is the Torsion. The Torsion is unfortunately still being delayed as we are facing manufacturing challenges of making the quality of the coating plating on such a big surface speckless.
Yep.
That's the shortest answer that we can give. It's still going to happen. It's a bit delayed.
Yeah, the like material and the machining and the workmanship that went into the case and its design is so stunning that we really don't want any to be you know, affected with flaws in the finish, particularly on the silver case. They're really visible. So we're still planning to bring a silver and black one with all the same accessories and features, and crucially all the same machining, but we really need to nail down getting them all flawless before the limited edition run starts, because it would be bad if we had to take numbers back and mess around. So there will be, again, a limited quantity as planned, but we need to get them all perfect first.
Next topic, roll the next two photos, is the Screen Edition O11D XL distro plate, which you were able to see for CES. Andy the lab did a build with this distro. Good news is it's coming in March, mid-March, late March, something like that. It is just the same distro as we have it for the XL, but it has the 7-inch screen at the bottom, which is a display piece if you just want to show neat stuff, or it's a very useful thing to monitor your PC's parameters. At CES we have seen other companies also trying the same approach, whether it's a case with a screen in it or a smaller case in smaller screen on the case itself. So we are glad that we are on the same track, that we are bringing the screens into the distro plates. If you want to see any other EK distro with a huge screen in it, typey, let us know which one do you want, and then we will try to make it happen.
I saw a good friend Varun asked us a question about the Torsion, and that was if the silver one also was affected in the same way, because he presumed that it had been like raw unfinished silver, but it's actually, we intend it to be anodized in the same way as all of our silver special edition products like the Founders Edition blocks, and it's also a really good match for the magnitude, really good match for satin titanium. So it was not planned to be raw aluminium, but it's definitely something we wouldn't rule out. We like anodization because it would look the same forever.
Yep. Next topic, two distro plates which are already launched, but we will mention them so that people are aware that these exist. One is for the Fractal Torrent. We should also see some images from the editing team inside the build. Anything special about this distro other than the frame? We are seeing the one for the.
That's that one.
That one. So let's. Okay.
So uniquely, the Torrent is the only quantum distro plate with a DDC. That's not to say there's anything wrong with the DDC. We needed it to be this thin to fit it behind the front radiator. If we had a pump anywhere on this, there's not enough space in the back. If we had a pump anywhere on this, it would block either the placement of ports for the hardware or the front radiator. So we chose the slimmest option we could pack, which is the DDC, and you can also fit the heatsink on, so it runs.
Also, if you would put a D5 on it, it would block the bottom radiator, right?
Exactly. Yeah. But you can still put a D5 on it if you really wanted and run just the back radiator or run tubes out to an external radiator. Can be done. Mechanically, the D5 will fit. But this is the way it's equipped, and we have this special bracket which simultaneously mounts the distro and offsets the front 360 just to the left side of the grill, and it has this really nice pattern which lines up perfectly and hides itself behind the original front plastic mesh. And then the second radiator goes down at the base of the case. If you have horizontal GPU, there's space for another P240 there, and then the tubes join directly between the two radiators, and the back ones go to the 2 ports on the distro. It's that simple, the same conventional 9-port layout that you find on all the other reflections. 2 ports for the CPU, and fill and drain are on the front side on this.
If someone needs inspiration around this distro, you can check out our YouTube channel. We have the AM5 build in the Fractal torrent. It's a white case. You have that build video, and we also have on the Shop the Loop page. If you haven't checked out Shop the Loop yet, you find it on our homepage. It is called Zen Lotus. The point of Shop the Loop is that you can buy all of the liquid cooling hardware which you see on the picture with a single click, and it's also easy to get motivation for your own builds and also how to use distros, because you have a complete list of fittings, which means that if you don't like that shade of fitting, you can just change it to a different finish, and you have the entire loop in your cart and just ready to roll out. We have 20-something builds in the Shop the Loop page, so if someone can drop the link inside the chat, that would be awesome. The next distro that we saw, the first in the big black case, is for the Corsair 7000D, right?
That's right, so it fits the 7000D and the 7000X, that's the case, right? The port layout on this, a little bit more complex than the Fractal. There are 2 dedicated ports at the top for the upper radiator. It can fit up to X360 at the top, and they will connect directly with just 2 tubes that go around each other. Same as always, 2 CPU ports placed on the Matrix 7 foundation position that lines up with most of the monoblocks you'll see from us, and down here the same 9-port layout for the GPU. These correspond to the first, second and third PCIe slot, and depending if you have a horizontal or vertical configuration, depends if you use this set of inlets or this top set of inlets, the top set of inlets being for vertical. And then at the bottom there are 2 more ports, and they are for the radiator which is at the front of the case, which would make it here.
Yep.
And again, one comes forward and one comes around it, so you can use a double 90-degree rotary offset 28 to drop down, loop around and connect 2 directly. If you keep the full PSU shroud in the case, you can fit an X360 perfectly in front of it. If you drop down to S360, then there's space for push-pull. And you can fit a 480 in the front still, but these 2 tubes will need to get routed down to the ports. And if you do that, you'll have to remove the PSU shroud, so there's space for the tubes and the radiator to go all the way down. So it's possible in this case to fit X360, X480, and that would be
again
awesome.
Again, the photos that you've seen with the Corsair 7000D with the yellow coolant, that's also on the Shop the Loop page. So if you want to look at it some more, or get the list of liquid cooling parts which are in it, just go to the page and you'll be able to find it and enjoy more photos of this build. Now, while we are doing photos, I will ask the editing team to show photo number 27.
Which someone magically beat us to it and asked us at the exact moment you asked to show the picture.
No, he is lagging, so we have beaten him. Yeah, I know. I know. This is a very good coincidence. We have borrowed this photo from Stuart Tonks, GGF, What do people think? Should we make a distro plate for this case? Just write yes or no, and we will count them. So that will be a nice baseline for us to know should we make it or not, and how fast. Before we move forward, I have to just do a little bit of magic here, and I'm gonna put this block here. I hope it's visible. I'm gonna put this distro here, like that, and then I'm gonna put this one here, and maybe people already get the point where we are going with this, right?
Right.
This is a concept that we came up with inside EK, because the company that owns these patterns, which I don't know, can I say the name of the company or not? Maybe the legal team will call me later, but the patent on these dots has expired a few years ago, and now everyone is free to replicate them. So we did as well. We have a distro plate here, we have a GPU block, and we have a CPU block. So let us know, do you think that this is something that you want to see in your own PC? Because we have enthusiasts about toy bricks.
Everyone is having flashbacks to CSQ.
Yeah, everyone is having flashbacks to CSQ. Obviously, we are using the larger toy bricks, but these are made for the standard toy bricks. What do you think, Joe? Can you read some comments? What are they? Oh, someone says no.
Yes, but I think they're Hyperion comments.
Ah, okay.
Because they're a few seconds behind us. So
Okay.
probably not telling us about Lego just yet, but
Okay.
there we go. Our favorite bricky bricks.
Yeah, so I think it's an interesting playing concept. This is also something to like bridge different hobbies that we all have. Some have cars and some will do toy bricks. This is how that does it look like with RGB on, and it also looks interesting on its own. But like I said, or like Joe said, oh, someone wrote the right word, and we don't have to pretend that it's something else anymore. But we are not going to say it because of legal reasons. For now, maybe we will get a collaboration with the official company. That would be super awesome, and we will of course try to get a official collaboration with them. But this is just an inside idea that we had, and we had to make some samples and test it. I'm gonna get these out of the way, and we will talk about one more distro, which we only have photos of, which was launched on Monday. It was a collaboration with Lian Li. We have collaborated with Lian Li before, and we should run photo number 28 and 29. We have some beautiful photos of this build. Is the build in the background?
It is over here, the purple one.
There it is. There it is. There it is. So this is a distro which is special, Joe, because?
Yep, so this is the G2, the successor to the massively popular G1. I think it must be
G-Wagon.
the most distributed
Distro plate.
Most distributed distro plate that has ever existed. There's thousands and thousands of G1s out there. So it was really tough to follow it up. Lian Li wanted something that would be more easily compatible with the Evo, since that's their fresh new case. So we devised quite an interesting mounting mechanism on the G2, which fits the original O11D, the XL, and now the Evo. And in each of them, it has a different set of holes, so it rests in exactly the right matrix 7 location. But you can still adjust it on the fan sliders if you have, different components. It can fit two 360s in all three of the cases that it fits. And now it comes as standard with the DDC, which is awesome. And you can also upgrade it to a D5.
We will be expanding on the compatibility list. We have a very basic compatibility list written on the product page at this moment. for the ease of use, but we will be updating that with more information soon. Also, the build in the background, which is using this distro plate, is also in the shop the loop, and I don't know if the video is up yet or not, but this will be the second shop the loop build, which will come with a step-by-step assembly of the whole PC. So putting the motherboard inside the case, cutting the tubes. There is also a chart describing the length of the tubes which have to be. So a like really step-by-step approach of how to build your custom loop liquid cooling build. It's for the Evo, but for all of the other two cases, for the XL and the O11 Dynamic, it's going to be a very similar approach.
Yeah, the main difference between using the G2 in the Evo and using it in the other two cases is that in the Evo it's effectively fully Matrix 7 compatible, and not only are the CPU and GPU placed perfectly for it, but the radiator position of the ports on the distro also corresponds to the basically height of the case, so they will fit with extenders. You can make it with just straight tubes in the Evo, and for that reason there's thousands of combinations of ways to put it together. In the XL and in the original, if you want it to sit in exactly the right place, then it's easiest to build it with bends. So our standard heights of extenders can't line up in all three cases because all three are different sizes. So we picked the Evo for it to have the most options, and in the other two it will still fit perfectly. CPU and GPU will still line up exactly as expected, but you'll just make either a simple band or a female-female or even soft tubing to the radiators, and that's it.
We have jumped over something which I wanted to mention, and we have it here, and we're gonna jump back to it. This is the EK Quantum Velocity to DDC AM5 block. This is also launched. We have it in the shop, and I think it's shipping in a few days. So it has been launched enough long so that it's on stock. This is a brand new sample from the production line actually. So this is how it's gonna be delivered to you. Small thermal paste and the quality tested EK sticker. No backplate because it mounts directly onto the board as a normal EK Velocity AM5 block. So you screw the little studs inside the board. It has all the same features as the Intel version, so 2 ports at the top, 2 at the side, and 1 fill port at the top. These side ports are still made that they clear G-Skill.
That's right, yeah, with small fitting style just clear G-Skills, and most other standard heights, but not extended heights like Dominator Platinum and such is a bit too big to fit with the ports on the side.
Off topic, we have seen a few complaints on social media about poor EK quality checks, and then people take photos of like blocks in random bags. So if you see someone taking photos without this seal and without this bag, that's a second-hand product, and probably that's the reason why someone is having issues with it. So this means it has been packed at EK. This is how it looks, and we can remind everyone that this is a big piece of brass, and underneath is the pump.
Yep.
And the coolant cools the DDC pump itself. Did I forget anything?
One topic that came up a few weeks ago was what orientations it's appropriate to install and run these combos in. Version? Yeah. The Intel version, but also applies to the AMD version because you may have a case with any orientation. It's preferable.
Okay.
It's preferable, obviously, to have the fill port at the top. That's the way it's intended to be. And here the pump is at the bottom, and the reservoir is entirely above it. It's also okay that it runs sideways, but you need to be really sure that it's full. It won't cause any harm to the pump, won't cause any harm to the unit if it runs this way or this way, but you know, just think how you're going to fill it beforehand. Make sure it's 100% full, and then it should be safe to use.
Actually, there's a plexi part here, and you can see the side of the reservoir here, and it's really easy to spot bubbles inside it because it has also RGB lighting. So it is really easy to spot that, you know, that it's not 100% full.
Yep, and obviously if the motherboard is perfectly flat in the case, that's also fine. What is not okay under any circumstances is to run it in this orientation with the fill port at the bottom, because the pump won't be able to suck coolant from the reservoir, or face down. I don't think I've ever seen a case with the motherboard face down yet, but don't try it because the pump bearing will be the highest point in the loop and has a very high chance of remaining dry forever, and it will die very quickly. So it's relatively versatile. It will fit anyway. A combo would fit, but that's not every orientation.
Before we move on to the RGB stuff, we have a few things here that launched recently. This is the expansion of the EK Pro line. So EK Pro line AM5 blocks launched recently, and 2 days ago, 1 day ago, 2 days ago, 2 days ago, we've launched the EK Pro blocks for the AMD SP5 socket. That's the new socket for the Threadrippers and also other workstation Epic CPUs. Is it still called Epic, right?
I think there are no Threadrippers this big, and that they're purely Epic CPUs that these fit, and they are made for the Genoa series of CPUs, which have up to 12 chiplets. So internally, this is a much bigger cooling engine than you would find on a Threadripper block or old LGA blocks. So these are huge.
It has 6 mounting points. It has massive springs so that the load is evenly spread. This is the AM5 block. Both of these SP5 and AMD blocks exist in versions where you have top ports, and you have the rack mount versions where you have side ports. This is the AM5 one, and we decided to make also the AM5 one because the Pro GPU blocks are also picking up. People like them, people buy them just because of the aesthetics. This is the water block for the NVIDIA A100, and it also has this recognizable Pro line finish, and we just said that we need some CPU blocks also which would work in a more mainstream environment with the looks.
Yep, and this AM5 block is awesome. It's best performing AM5 block at the moment, and it's also the first Pro CPU block to feature Matrix 7 spacing and Matrix 7 flow direction. So just like Velocity 2, this is the inlet and the top port is the outlet, so it bleeds easily. It does have a biased cooling engine towards the CCDs, so you have all of the cold coolant going down, spreading and hitting the CCDs, and the fins are vertical, again with a staggered jet, so that the coolant's balanced between going over the I/O die and returning around the sides.
I just have to mention that the copper starts here and it ends here.
Yeah, it's all copper.
It's all copper. It's heavy. Anyway, do you want to talk about some GPU blocks now before we move forward? Yeah,
let's look at all the rest of the GPU blocks on the table.
We have one GPU block there, and let's talk about that one.
So this is the special edition specifically for the 7900 XTX reference. You can buy your reference card from any of the vendors, but it must be an MBA made by AMD card with the reference cooler, which this takes its design inspiration from. And I think this is one of the most awesome special edition Radeons to date. It's an awesome tradition that we have with Radeons going back to the 5700 or before.
5700.
5700, and then the bumpy one, that was awesome, and last time the big X-shaped Radeon. And now we adopted a design quite similar to the Founders Editions, the special Founders Edition, with the window, hidden screws, and very similar assembly mechanics to that.
All of this top is aluminum, right?
Yep.
So the black piece here is aluminum, again, not touching the coolant, like it shouldn't.
Yep. So
Take notes, people.
It's a 10mm machined aluminium plate with a lot of kind of 3D machining on the exterior. And on the inside, it actually sandwiches the plexi and pulls it down onto the copper, but there are no threads in the plexi. It grips it around, pushes it against the O-ring, and seals everything up nicely.
This is the best thing about it. For me, this is the best thing about it. Someone might prefer backplates. Oh, this is actually the backplate. Someone might prefer backplates like this, so very minimalistic, but for some reason each GPU backside has some texture to it or some shape, and that's why this really works for me. Let us know in the comments, do you like shapes on the backplate or you prefer them to be really clean? We have also managed to see on the market that this terminal was very inspiring to another boutique liquid cooling company. Some might not notice it or not.
It's a pretty one.
Yeah. It features the same magnetic cover that you can flip the Radeon logo if you are using it in vertical, so that you have it pointing the right way, or reverse ATX. Anything else we have to talk about this block? It's a very intricate shape.
Yep.
Which is modeled after the air cooler. So.
Yep. I think it's also worth mentioning the cooling engine, even though it's the same as all of our 7900 blocks, but the fins are oriented vertically on purpose so that 100% of the coolant spreads across the graphics die. If they were horizontal, then only 30% of the coolant is actually going to pass over the graphics die, and the rest would just pass over the V-cache dies. But in this configuration, then everything receives equal amount of coolant and an equal temperature of coolant. So that's a big advantage this block has over other blocks designed for the extremely thin, slender, high-density die that's on the 7900s. This does not fit the XT, unfortunately, because the XT has a smaller PCB. And someone asked in the chat if we were considering any more Radeon blocks. So this generation we have the Tough, we have the Reference, which you can get in vanilla Vector 2 or the special edition form, or limited edition form. We're only making 200 like this. And then we will have the Red Devil as well. It's also available as a Liquid Devil with the card.
It launched last week.
Yep.
Yeah.
And now we're contemplating, should we add the Sapphire cards? So the Sapphire Pulse and Nitro Plus, XT and XTX, so all four combinations there, would all be able to have the same block. As we understand, the Sapphire is pretty available around the world, so if that's a PCB design you'd be interested in, let us know. Or if you think there's another 7900 that we should look to do first, also let us know.
We have only 4 more topics to talk about, and then slowly we will end this live stream. And the next topic is this terminal right here.
Yep.
What does the terminal tell us?
So this is a very interesting terminal that can do a whole bunch of stuff. So its primary purpose was just to shrink the width of the card as much as physically possible. So if you have a right angle power connector from CableMod or your favorite vendor.
Oh, they have launched the angled in green, orange, red.
All the colors.
Millions of colors.
Awesome. Yeah. So if you have one of those and you want to keep this really tight in your case, then you can now pop on this guy, and you can see it takes a massive amount of thickness off the terminal. It's fastened in exactly the same way with the 3 screws and the magnetic badge and you can put your Radeon or GeForce badge back on. But it fits slightly differently. This one doesn't lift up from the ends because the block's so thin. You have to flip it up from the side. But anyway, and then you get 6 ports. So 3 at the back, they are the inlet, and 3 at the front, they are the outlets. So if you connect this maybe back towards the CPU block in parallel, you could bring a loop passing directly through it in a straight line. The height and space of this port is exactly the same height as a rotary fitting on a normal terminal, but it's 21 millimeters further back, which means if you put this terminal on a full-size card like a Strix or a Trio for the win, whatever it might be, it effectively puts your ports back in line with the distro plate as if you had a reference size card.
Here we have a normal GPU block, and we can compare the reduction in the size for the terminal. It's quite significant. I think it's around 10 millimeters or even more.
Yep.
I think that's coming next week or something like that. It's not going to be cheap, but the way that we looked at the market, other similar or even the same idea solution with less ports cost around the same. So I think that we will remain quite competitive with this product, given the fact that this also works with Matrix 7 and that it still makes your liquid cool building process easier because it's in the same dimensions as, like Joe mentioned, this aligns with the distro and things like that.
Yep, and if you were wondering, if you have an idea for a build already, you can flip this around so the ports are all on the block side. So, you know, if you really want to mount this flat against something, it also makes it thinner in this plane than having a normal block with the ports on. So you could put it right against a window, or you can do the opposite and put the back, you know, way in the back of a case or on the floor, or any number of different things. So this opens up a lot of new placements for GPU blocks.
That's the only new. Oh, we will also have a side port terminal, which we don't have the sample here. It's a standard size terminal which has ports on the side. That will be good for miners, right?
Be very good for miners. There'll also be an active backplate version, so you can drop loads of 3090s together and have them all mine away, which sadly not so profitable anymore, but you know.
Maybe it'll come back, maybe someone needs it for some special reasons.
Or maybe you can use them for fold at home like the good old days and do some good with your old mining rig.
Before we have 3 more things to talk about, so one down is we're moving to these fans. We have talked about these fans. My RGB cables are not being so solid here. So we have talked about these fans 1 year ago, right? And finally we can say that they will be coming April, May, something like that. These are the EK Quantum Impulse fans. So these are the RGB heavy fans which have RGB in the front of the frame. The hub is lit and the back side of the frame as well. I'm going to turn the RGB back on so that you see that there's RGB also in the back. It has this beautiful brushed aluminum badge on the back and the front as well, which removes all branding, so every information about the products is on this small tab which you can rip away, which I always did on every other product. It uses the 8-pin microfit connector, same as the FPT fans.
Yep, so you can also connect them directly in series with FPT fans, or you know, one on one side of a radiator, one on the other, anything like that.
These plugs are black, but on the final version the cables and the plugs for the white version are going to be white. The black is going to be black. It has huge rubber corner dampers. It has a lower performance than the FPT fan because the blade has to be smaller because of the integrated RGB in the frame. The Phase is also moving forward, which is a high performance version of this fan actually, which has only RGB in the hub.
Yep.
What else I have to say?
These are slightly slower than FPTs and you know, ER Vardas that you might be used to. These are 1850 RPM, I think.
Yep.
So a little bit slower, a little bit lower maximum noise level, and very well suited to cases, to open places, and to less restrictive radiators. They're not the right choice for X series surfaces, but for S's and places where you want them to look super fancy, that's the one.
Let me try. Oh, okay. So here, yeah. So here you can see different applications. I think these look great, but like we said, these fans are oriented to aesthetics, and if you want the higher performance, you will wait for the phase fans. Phase impulse out of the way. This, we have to talk about this. So the mouse pad that you see on the table is actually the one that's inside this brand new sealed box here. So this quantum decorated mouse pad is finally coming to market. It's gonna launch early March. I will try and make sure that the first few people that are gonna buy this pad gets a special deal, so that we spread the word that this mousepad is available. So keep your eyes peeled in the first week of March about this launch. What can we say that we haven't mentioned about this pad yet? It has,
I mean, it's excellent.
Yeah, it's excellent.
Yeah.
Buy it. That's it. Case closed. It has many features of the Matrix 7, so it explains the extender heights, radiator thicknesses, the port spacing on the radiators. It has all of the most important fittings and the extenders here, offset fittings also listed. And just to prove a point that I'm not lying,
that we have more than one.
Yeah, that we have more than one, and it actually comes out of the box. I'm gonna just...
Oh, you have to roll this up when you take it home now.
So there you have it. That's how it looks. Now we have two of those, and you can have one as well. Last topic is not so strictly quantum, but it's still an EK product, and we really like it. We will need those two boxes, and we will do a mini unboxing. Sure. Thank you. So Joe will have this one.
Oh, that's my favorite.
And I'm gonna have this one.
I like this one.
This is the Nucleus 240 in white. We had questions about the white version. We are not able to talk about any launch date, but it's really not going to take that long. It's closer than you think.
I wonder how long it's going to take to get to the Isle of Wight.
Or how long it's going to take for us to have white fittings. Some of you might have seen already reviews for the regular Lux version, which is an RGB version. This is the dark equivalent of the former AIO, the basic. Sorry, the equivalent of the basic, which is called dark. It has no RGB. It has black fans with no RGB. It still has the daisy chaining. What Joe is doing here is actually J2 Sense received samples of the regular Lux, and J2 Sense commented on this packaging, and he thought that it's part of the reviewer's kit, but those who haven't seen the Nucleus AIO yet,
it's got stickers.
It has stickers.
Everyone gets stickers.
You have this nice box. All of the accessories are in this box. So this is how the retail product ships. There you have it. So this is the accessories box. What I really like about this is this tool, which I can get out. Maybe I have to move this. So in here is the mounting, the backplate. You can use this tool to screw on the standoffs, so that you don't bust your fingers near this socket, so it goes on like that, and you just can tighten it. This is brilliant, mind-blowing for me. You will probably expect how the black version looks like, but we're gonna unbox the white one because I also haven't seen this yet live. This is the first time I'm gonna see it. I'm gonna put this back because this might end up at someone's doorstep, a reviewer. So this is the white version. I already see it has a silver. Even the fins are white, Joe? No. I'm not gonna put out the fans because the fans are just the regular EK FPT fans. So there we have it. I'm gonna put this right here. So that's how the white version will look. I really like it.
Yep, and this white one has the same RGB as the Lux black model. So little fins inside. They spread even just a bit more because it's white.
Yep. So I like it. Now I want to do a white build again.
It's properly white.
So again, April, May for both these models. Supply chains from China are not the best these days, so bear with us, be patient. Thank you. Radiator is also coming back in stock soon, so again, bear with us, be patient.
A lot of back orders shipped in the last week, so we're now catching up and getting close to being in stock again on all the radiators.
Yep. But that's kind of it for this Strictly Quantum. Thanks everyone for staying until the end. So everyone who stayed until the end. Also thanks for those who just popped by. Also thanks to Roman for being our first Strictly Quantum guest. Joe, any final words for this show?
No, it's been a lot. You said we had little this time, and we had
a lot,
a massive amount, a huge insight into what's coming with AM5 direct die, with AIO direct die potentially, and
the crazy monoblock,
the
black AIO and the white AIO.
And if you make enough noise, the Hyperion case and the 7900 XTX for the Sapphire card, perhaps.
And the mousepad. Oh yeah, this is actually.
We got a lot of work to do.
Yeah.
Yeah, we should probably go.
Yeah. This was actually quite productive. Once again, I can take these gloves off because I'm not gonna touch any of these beautiful products anymore today. Thanks for joining. Take care. Bye bye.